Hi everyone and welcome to this GLA homework review video for Block 2 Week 3. In this video we're going through the maths homework. There'll be a corresponding video that goes through the English. So here are our books. Again, as will be the last time, I remind everyone that please ensure that we're only bringing back the maths and the English books. I did say at the start of the last few videos, but just make sure please that we've only got the stuff we need for this block. And of course the other reminder that make sure at the end of the block you keep these ones safe, because we're going to be finishing these off in Block 4. Let's jump into the actual homework. You can see here it's week 3. It's a nice succinct one here. We're going to be going through the written division skill pages on page 28 and 29 in the Minecraft book, along with some division tasks, and then going on to the online. With the online this week, because you've now done both multiplication last week and division this week, when you come to the online you're actually welcome to do the division and the multiplication, or try and just focus on the division half of this, because I know last week you were encouraged to only focus on the multiplication half. This week I shouldn't think should take too long in terms of the amount of content, so one thing I would also recommend looking at within the You Could section, because these are really good activities, is just the mixed calculations within the bond book. The mixed calculations are lovely just because you're going to go through and do a bit of addition, subtraction, multiplication and division, and that will sort of sum up nicely the last 3 weeks. So even if you don't necessarily get a chance this week to go over the You Could, perhaps in the holiday, or certainly before the week 5 assessment, it's well worth just flagging this You Could down here as something you may want to take a special bit of attention towards. And because we're still doing multiplication division, it's now going to be in the same place as before. You may already have a score in here, but that would be from last week where we had asked you to just do the multiplication. So hopefully now you can take your medium score and boost it up to a larger one. It's important to remember with these online ones, they are challenging, they are tough, they're really good practice, and well worth going through slowly and sort of looking at the hints and tips for each question if you're not sure. But please don't be too concerned if right now they're still a bit difficult with some of the questions. You're welcome to just click in multiple times and just work through the questions that you can. And over the course of the year, what we expect to see is a gradual improvement in how these things go. Right, then let's jump into the actual mainline homework, which is of course the division here. And the first page is page 28 inside the Minecraft Maths book, so it's this top one here. And it's just like this, it's written division, and it's just really using the short division bus stop approach. And so I'm going to do all these questions with you now, and just hopefully highlight how I would go about approaching these. One thing I would say, obviously the book is it's a certain size. When I'm doing these, especially depending on how good your handwriting is, if you do need these to be larger, you do feel the need for more space, obviously you're more than welcome, and this is true for any of the maths questions that you're doing, is to, in your jotter book or in a piece of paper, you're welcome to rewrite the questions and simply draw them larger. So for example, if you are someone who needs a bit more space, I tend to find, for example, for this first one here, look, I'm really exaggerating the gaps at the top, and that gives me space to put, for example, my remainders. So that's one thing that you're more than welcome to do. So for this first one here, which is 8 divided into 136, I can now go through and really clearly say 8 goes into 1 0 times. That gives me a remainder of 1, so I've got myself a nice space to leave it here. Again, really making sure to make this one, the remainder 1, smaller. I don't want to see any remainder 1s that look like this, because this can then really start to mess with people's place value and they end up having answers, but they're in the wrong positions. So make sure your remainders look like remainders nicely and clearly at the top. 8 now goes into 13 one time. The remainder between 8 and 13 is 5. And of course 8 does go into 56 7 times. I'm keeping everything nicely in place value. I can obviously tell what my remainders are and what my normal numbers are. So this is what I mean about rewriting it, and certainly it's better to have it nice and clear in another book, and you can always then transfer the answer over here to be, for example, 17, rather than doing it all cramped and horrible and being unclear. So if ever you need to with maths, do rewrite it for clarity. Always a good idea, always well worth doing. Okay then, right, so on now to number B. So here we've got 14 into 25. 14 goes into 2 0 times. We need a slightly smaller pen tip there, so it goes in 0 times. The remainder is going to be 2 because none of the 2 got used up. 14 won't go into 25 more than once because 2 lots of 14 is 28, which is too big. So we know 14 will go into 25 one time. Now the remainder between 14 and 25, well, it's 6 to get from 14 to 20 plus 5, so that's a total of 11. So I've now got to do 14 into 111. Now with this, 112. 14 into 112. Now, with this, there's a few ways of doing it. You could, and this is probably my recommendation if your timetables aren't that strong, and certainly if it's like a 14 times table, where it's probably not a very familiar one, I would just, off on a separate piece of paper on the side, start listing out your times table. But there are some tricks. Because I can tell 112 is quite a large number, I might just start doubling, because I don't find doubling too tricky, and that might save me some time. So if, for example, I do 28 times 2, that takes me to 56, and 56 is quite an easy one to double again to get to 112. Now, if I want to work out how many 14s that is, I've just got to sort of keep track. So this is obviously 1 lot of 14. This here is going to be 2 lots of 14. Then I doubled it, so that's going to be 4 lots of 14. And I double it again, so that's going to be 8 lots of 14. So you could either write out the times table in full, or you can do this trick where you sort of just double it down, and so that means I now at 14 goes into 112 8 times, giving me an answer of 18. So that's a useful little tip along the side, and certainly something I would be doing for any of the numbers that I'm less familiar with, so possibly the 13, the 16, the 25. These are all ways or approaches for handling that question there, which hopefully makes sense. So I'll rub out on this one here just so I've got more room. Right, and carrying on. So does 13 fit into 5? Sadly not, so it goes in 0 times. The remainder is 57. So again, a 13's on the table, I'm not that familiar with it, so I'm going to start writing out. So I'm going to do 13, 26, 39, so far that's quite friendly. Then 39, excuse me, plus 13 is a little harder. For that one, you need to do obviously the 9 and the 3 first, that leaving us with 12. So I've got carrying the 1 plus the 1 from 4 takes me to 52, and that's pretty close to 57, so that's going to be 1, 2, 3, 4 times. And then the remainder between 57 and 52 is going to be 5, giving me 52 again. I already know that goes in 4 times, so the answer therefore must be 44 for this one. 16, we've got 16 goes into 1 0 time with a remainder of 1. 16 fits into 19 1 time, remainder 3, and 16 fits into 32 twice. That one I can handle without needing to list it. If I did need to, I would just sort of list down the side 16, 32, and then you can see here we know it goes in 2 times. When you are doing this timetable listing beforehand, so for example here I've listed 13, the 16, I would not list it any further than you need to. And what I mean by that is don't preemptively be like, oh, well, this question here, I need 16 times table, let me quickly write out from 16 right the way down to 10 times 16. Instead, only working out as far as you need to, just to save yourself some time. Right, on to this one here. We've got 25 into 4. Well, that doesn't work. No times. Remainder of all 4. 25 into 42. Well, it can't go in more than once because 2 25s is 50. So it means it's going to fit in 1 time. And then the difference between 42 and 25 is going to be 17. So that's going to be 175. This is where I might start listing things out. Luckily, I happen to know that 4 25s is 100. So that's 4 of them. And then 3 25s is 75. So 4 25s and 3 25s means I know it's going to fit in 7 times. And finally, 25 fits into 0 times. So again, this is a variation of the theme where rather than listing out the full 25 table, which you could absolutely do, and you'd have listed it out 7 times to get to 175, I'm using some mental maths I already know, that 4 lots and 3 lots makes 175 to save me some writing time. For number F, just to point out beforehand, that decimal is going to change nothing, but the only thing I can preemptively do is just line these 2 decimals up nicely, because again I need to keep on my bus stop perfect place value, so I already know that the decimal is going to stay there, and there's going to be what numbers on either side of it, keeping everything nicely aligned. So 5 fits into 7, it goes in 1 time, remainder 2. 5 fits into 21 4 times, remainder 1. I just carry the remainder over like normal, basically ignoring that the decimal's there. 5 goes into 15 3 times. I write the 3 as per usual, but because I've already set out here the decimal place, I know the answer is 14.3. So I know the decimals can look a little intimidating, but really, guys, you just treat them the exact same way. Pretend they're not there. And if you can get the full hang of all these questions, you can pretty much say you have nailed the division, because it is not going to get any more complicated than this. And this shows a really good mastery of the division, which is really useful. Number 2. Rosa wished she had a stack of apples to give her a boost in pounds and pence, and a stack of 15 apples costs £4 5p. How much would one cost? Well, we're going to be dividing the total cost, which is £4 and 5 pence, by 15. That's how we're going to work this one out. So I can preemptively put my decimal in place, get it all nicely lined up. 15 does not fit into 4 0 times, so we get a remainder of 40. 15 does fit into 40 because 2 15s is 30, so that means it fits in twice. And there's a remainder of 10, so I carry all 10 over. And now I do have to do a remainder, so for this one I might just list it out. So I'm going to do my 15, 30. You could do the trick of doubling, but for this one, just to show you completeness, I'll do it properly. So we can keep going, 45, 60, 75. We've then got 90 and 105. So if I count out, we got 1, 2, 3, 4, 5, 6, 7. It goes in 7 times, which means the answer is £0.27 or 27 pence. Since they asked for it in pence, we have to make sure we convert it from pounds to pennies. And so there's a good example. So guys, if you're having to do this for every question, oh sorry, I can't see. You can't quite see on the side. Look there, I've just listed out my times tables, and I've counted them going down the side. So if you do need to, just as you're going through, just list them out. It's no pressure, no bad thing to do that. And this is true not just for the harder times tables, but even things like the 8 times table. If you're unsure, just listing the times table down the right hand side is often a lot faster than sort of not doing anything and waiting for sort of inspiration to strike. It's far better to take action, just start listing the times table, and then that'll speed you along your way nicely. So here we've got some larger divisions, and we're going to treat them the exact same way, but nicely now they've given us the space to set out how you want. So I'm going to choose to just give myself some nice bits of room. One other thing I would always recommend is never ever ever in your working add a comma. It's all too easy for the comma, which is meant to be here to represent the 6,000, to start looking like a decimal, and that can really confuse things. So my advice would be, when you're actually doing the working out, use nothing, and then your final answer, if you want to, you can add it back in, but certainly in the working out, I would always recommend leaving the comma not there. And hopefully you can see how I've just set it out, giving myself a nice gap between, because I know there's going to potentially be remainders, so by leaving a gap, I'm giving myself plenty of space. Jumping into the actual questions, we try and put 7 into 6, it doesn't fit, it goes in 0 times, so there's the full remainder then of 6. 7 into 62, doesn't quite go. We can do 7 times 8 to get us to 56, which is pretty close. 7 times 9 is too big, it's 63. So that means we know it's going to be 8, with quite a big remainder between 56 and 72. That's going to be the remainder of 6. Nicely, 7 does go into 63, it goes in exactly 9 times. And 7 goes into 0, 0 times. So my answer is 890. On to the next one, we've got 7, 5, 7, 8 divided by 18. 18 definitely can't go into 7, so that's a 0, 7 times. For this one I might want a bit of help sort of doing my 18 times tables. This is where I'm definitely going to start listing things down the left or down the right hand side here. So we've got 18, 18 doubled is going to be 36. Oops, right, 18 plus 18, I can handle that, that's 36. Plus 18 again is going to be 54. Plus 18 again is going to be 72. So that means it's going to go into 75 4 times, with a remainder of 3. I can see from what I've already conveniently listed out here that it's now going to go into twice, remainder 1, and 18 goes into 18 1 times, so 421. Again, for here, I might potentially need my 23 times tables, so I'll do those sort of on the side potentially if I need to, but we'll see how it goes to start with. So we've got 4,715. Again, give yourself a nice bit of space, drawing it spread out, so I've got plenty of room. Divided by 23. 23 goes into 4 0 times, remainder 4. 23 plus 23 is going to be, I can handle this one, it's going to be 46, so it goes in 2 times, remainder 1. Here we have 23 going into 11, 0 times, so the full remainder comes across. This is where we might now have to start doing our 23 times table. So we've got 23, 46, 69, 92, and then we have 115. And it'll often be the case with these guys that it will go in nicely, so that's 1, 2, 3, 4, 5 times. So the answer is 205. Last, you've got £3.99 or £3.99, doesn't actually say pounds, divided by 21. So again, if I need to do 21 times table, I will do it on the side, but I won't start writing it as I need to. So 21 is going to go into 3 0 times, going to keep my decimal in the same position, carry the 3 over. 21 is going to be 21, and unfortunately it's 42, so it means it actually goes in one time. The remainder between 39 and 21 is going to be 18, so it's remainder 18. And so definitely for this one I'm going to want to start doing my remainders, my addition down the side. So that's going to be not too bad, this, because we're just adding 2 and 1 each time, so it's going to be 63, then 84, then 105, then 126, 147, 168, 189, which is the number we needed. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So it's 0.19 is the answer. Again, they're just larger, and there's not a great deal of difference between these two, I think, as long as you remember to ignore the commas or just add in the decimals as you go through. Hopefully that was clear. Hopefully that was, if you can see there, I was utilising the writing out of the times tables a bit more for these ones, because as they get less and less familiar with them, and I'm sure the same for you guys at home, you don't often practice your 18 times tables, but as long as you're able to work out as you go through, and again, equally notice how I'm only drawing it as far as I need for each individual question. I think that's quite important as well. Right, Rosa can stack 64 bricks into one storage slot. How many would she need to have 1,020 bricks? Okay, well, it's still just a nice division. So 1, 0, 2, 0. We're dividing by 64. So this is certainly one where I may need, I'll probably want to have the 64 times table written down the side, because I'm not that familiar with 64 times table. We'll see how we go first. So 64 into 1 goes 0 times, remainder 10. 64 into 10 goes 0 times, so the remainder is now 102. Now this will go in, so 64 will go in one time, but the difference between 102 and 64 is big enough that I may even consider setting up a subtraction like we'd have learnt in week 1. So in this case I've got to borrow from the hundreds to get 10 tens, borrow from one of those tens to get a 12, and now 12 take away 4 I can do, which is 8, and 9 take away 6, which is 38. So we now know 64 goes in one time with a remainder of 38, which means we've got 380. And now I'm going to have to do my 64 times table. So that's going to be 64, 128, 192, 256, 320, and then obviously 384. So, if she wanted to store all of these bricks, now in this case this is one way we're going to sort of bring in an element remainder, because we go 1, 2, 3, 4, 5 times, but there is going to be a remainder element. But the nice thing about this is because we don't actually need to know what the remainder is, we just need to know that there is a remainder. My answer is actually going to be 16 storage slots. And the reason for that is I know she's going to need 15 and some more. And since you can't have half of a storage slot, half of a chest, or whatever it is, the answer is going to be 16. Now, of course, as it turns out, the remainder is not too hard to work out. It's going to be the difference between 320 and 380, which is remainder 60. So basically, she's going to need 15 full slots with 60 bricks in one of the slots, but that still means we need 16 slots. So that's how you can see how I've got this 16 from. So hopefully that makes some sense to everybody. So for this last one, I might just make myself some space in case I need to list some more times tables out. So the Creepy Stronghold has got 1,680 mossy cobblestone blocks. And they're equally spread across the 24 rooms, so we're dividing by 24. And how many are each room? Okay, well, let's go through. So 24 goes into 24 goes into 1 0 times. 24 goes into 16 0 times, so we've now got 168. This might be where, again, I'm going to need my 24 timetable, 24 added listed out, so that's going to be 24, 48, plus 24 is going to be 72, 96, 120, 144, and then finally 168, I think, which is good. So it goes in 1, 2, 3, 4, 5, 6, 7 times, and then 24 goes into 0 times. So that means there are going to be 70 bricks, mossy cobblestone bricks, per room. Again, hopefully you can see how we worked out. And again, we did have to work out our 24 times table, but that was okay. That wasn't too bad. Right, guys, give yourself a score out of how many you've done. There are 5 questions. Remember, you get a score based on the emeralds for each one. So if you tot up your emeralds, you can sort of shade them in at the bottom here, or you can just give yourself a score out of each mark. But I would make sure, for example, here, I would consider each of these questions 1 mark. So you have to work out what it's out of and give yourself a score, just so that then when we get to the end, we can more easily write down the score. We're now going to move on to the division with remainders task. This is on page 30. So in this case, we just need to be aware that we're going to have remainders left over at the end, and that's absolutely fine. One thing that's important to note is what do they want you to do with the decimals. So for example, here I'm just going to pre-highlight that in this case they want your remainders as decimals. The way you do that is really important that you understand. Essentially, you just keep going until you have an answer. So I'll show you with this one as an example. If you have 193 being divided by 5, you can just give yourself 193 point nothing. And if you now just keep going, instead of putting remainder something, you've now given yourself a space to keep going. So I may just do this 2a as an example right off the bat. Just in that case, anyone's not had a chance to try these questions, they can go away, try them again, and then come back and get the answers when they want to. So allow me just, if you would, to do this slightly out of order, just because this one specifically asks for decimals. So in this case, does 5 go into 1? No, it doesn't. We've got a remainder of 19. 5 does go into 19, and it goes in 3 times with a remainder of 4. 5 goes into 43 8 times with a remainder of 3, whereas we would have written previously 38 R3. We've now got a space to put that remainder, and 5 goes into 30 very nicely. And so my answer to this first one is going to be 38.6. So nothing about the actual method changes. You just have to know that you're allowed to add on or extend as many zeros as you want at the end, and it will still work the same way. And you can do that. My advice would be obviously only add in the zeros as and when you need them, but that is how you solve those questions. So hopefully that makes sense for question 2. Right, let's jump back at the top now and do them in the proper order, but hopefully that was just to give everyone a bit of a hint as to how to get started so they can give question 2 a go if they needed it. So let's get the size back to where it should be. So Rosa has 188 eyes, and they can be used to fill portals, and each one holds 12. So how many portals could you fill? Well, that is going to be 188 divided by 12. 12 goes into 1 0 times. It goes into 18, however, 1 time, and the remainder is going to be 6. And 12 times 6 will work, although it may not leave a perfect answer. In this case, we have to interpret what the remainder is going to be, but let's actually first work out, just moving over, what the remainder is. So we've got to do our 12 times table, so if we do 12 times 5, that's going to be 60. So it means we know it goes in 5 times, and whereas before we would have done a remainder 8, in this case we have to sort of interpret what that means. So we know that she can fill completely 15 full portals, and there'll be 8 left over, which I don't think is enough to fill up a portal, because it needs to have 12. So I think the actual answer is going to be, for this one, just 15. Realising that the remainder 8 doesn't help us achieve our goal. For part B, however, how many would be left over? Well, the remainder was 8, so I think there's going to be 8 left over. And that's sort of how we would interpret question 1. It's about understanding, I guess, what the remainders actually mean. Right, for number 2, I'm definitely going to do the same trick as before, where I add in the zeros, but I will add them in only when I need them. So looking here, so we've got, does 12 go into 4? Well, no, it doesn't. It goes into 0 times, which means there's a full remainder of 12. If we do 12 times 4, we get 48, so it's going to go into 49 4 times. Remainder 1. 12 will go into 15, it will go in 1 time, remainder 3. I need somewhere to put the remainder, so I'm just going to add in my 2 decimals and a 0, because and the reason this is allowed is because 495 and 495.0 are the same, so I'm not changing the question at all. It's not changing the values, but now by putting 0.0, I've actually got a space for where to put that 3, and so I can keep going. 12 does absolutely fit into 30, and 12 goes into 32 times, remainder 6. Again, I need a space to put that, so I can add another 0, and now I've got a location to put that 6, and 12 goes into 65 times. So my answer is going to be 41.25. And again, guys, if it is starting to get at all cramped here, I would strongly encourage you for these questions, just rewrite them in a book elsewhere. It's fine if you can fit them in, your handwriting's nice and neat and clear, but if you do need to rewrite these questions, that's absolutely fine. It does mean you can then rewrite yourself, giving yourself plenty of room which I do think is a good idea if you need it. And that's probably what I'm going to do actually for C as well. So we've got 24. 3, 7, 2. 24 goes into 3 0 times. Remainder 3. 24 goes into 37 1 times. The difference between 37 and 24 is 13, so that's going to be remainder 13. So that goes in 24, so we might have to list the times table out for this one. So 24, we've then got 48, we do another, we get 72, then 96, then 120. I don't think it will fit one more time because the next one is 144. So that means we're going to fit in 1, 2, 3, 4, 5 more times. Again, we need a space for the remainder, so we're going to add in the 0.0. This gives us a space to put our remainder. The difference between 130 is going to be a remainder of 12. And then we can nicely see, because we've already got it pre-written out, how many times 120 goes in. 1, 2, 3, 4, 5. So the answer to this question is 15.5. Let me rub these ones out here now just to make some space for my workings. So for this one, we've got 4 into 432. Also 423. Oh, this is quite nice. 4 does go into 4 one time. 4 does not go into 2, however, so the remainder is 2. 4 does fit in 23. It fits in 5 times remainder 3. So I give myself somewhere to put that remainder 3. 4 does fit into 30 because 4 sevens are going to be 28, remainder 2, and 4 into 20 is going to be 5. 107. Done. So last two, we need to do 16 into 2, that goes 0 times. Carry the 2, so now 16 into 20, that goes in once, remainder 4. 16 into 45, that one I might just quickly write out my 16 times table, so 16, then 32, then we're going to add on another 16, so that's going to be 48, that's too big, so I know it only goes in twice. And the remainder is between 32 and 45, so let's just do that here. So 45, take away 32, that's going to give me a much bigger remainder of going to be 13. So we've got now 130. So now we definitely want to keep going our division down here, or our adding on, of the 16 times table. So we do 48 plus 16, which is going to be 64. And then we need to do another 16, which is going to be 80. And we'll keep going until we get close. So that's 90, then so that's 96, which is nice and easy. 112 and 128. And obviously 100 I can see is less than 130, so that goes in 1, 2, 3, 4, 5, 6, 7, 8 times. I need a space to place it, so add in my 2 decimals. Oh, sorry. First off, it goes in 8 times. Now I need a space to put the remainder, which is the 2. I'm going to write that here. And this one is going to go through 20 times we've already seen. That's going to go in 4 times. So I think I know what's going on here. So we're going to have... keep my line going. So it's going to go in 1 time. The remainder is going to be 4. So we need to keep that going. Giving ourselves another 0 to write it next to. Into 40, I can see that's going to go in 1, 2 times again. This time the remainder is 8. Giving myself another 0. And 16 into 80 goes 1, 2, 3, 4, 5 times. So my final answer is 128.125. Cracking division question. And you can see how it's really useful. The fact that I wrote all these times tables right the way down, meaning when I needed to do 80, suddenly the information was already there, ready and raring to go. I might just move these ones up and out the way. So let's just grab that and put that up there. Right, last one is this division of 8, or division by 8. So let's quickly do it. So 8 does not go into 1, it goes in 0 times. Which means we have to ask ourselves how many times 8 goes into 19. Well, that goes in twice, remainder 3. Here I might want to write my 8 times table out, so I've got 8, 16, 24. I might have to squeeze one more in, 32, so that goes in now 4 times. Remainder 1, keep the decimal in the same place. 8 does go into 12, it goes in 1 time, remainder 4. 8 goes into 40, 5 times. So my answer is going to be 24.15 for this final question on number 2. So hopefully that makes sense, guys. Hopefully you can see where those answers are coming from. I think the really useful tip, and this is true for divided by 24, 16, or even 8, is just to list out the times tables just to make really, really certain and to not get put off by the decimals, because as you can see, really they work sort of the same way. And actually, I think number 8 was a nicer question than number 16 for the exact reason that we were able to just get on with it, pretend the decimal isn't there really. As long as I add the decimal above, it makes it quite a nice division. So we've got one final page. So obviously it has some nice stuff about Rosa doing her Eyes of Ender, but fundamentally we have to end up doing a number divided by 45 is 156, remainder 32. So it then asks you what the number is. This is a really good test of just understanding what remainders are. Basically, we know there were 156 lots of 45, so we have to do 156 times by 45 to get back to where we were, but there were 32 left over. So whatever this answer is going to be, it's going to be a multiplication to find out what 45 lots 156 are. We're also at the end, down here somewhere, we're going to add on 32 to get our final answer. So that's sort of the long-term plan. And so actually this is good because practicing the skills from last week. Can we remember how to multiply? So the way it works is 5 by 6, which I like to put my lines in as well. So 5 times 6 is 30. So carry the 3 and write the 0. 5 times 5 is 25, plus the 3 is 28. And 5 times 1 is 5, plus the 2 is 7. So we've got 780. So 5 times 156, which is what we've essentially done on that top row, is equal to 780. On the next row, we're going to do not 4 times 6, but 40 times 6. And to help us remember that, we're going to put the 0 in this place here, because that's not a 4, it's a 40. And by writing this 0 here now, we can pretend or treat this 40 like it's a 4 times 6, and all the numbers will end up in the right place. So, to give you an example, when we do 4 times 6, we can just carry the 2 and write the 4, even though what we've really done is 40 times 6, which is 240. But if you look, that's actually what we've written, because we've written the 2 in the hundreds column and the 40 in the tens column. But it makes it just by writing the arrow and then just pretending it's not there, we can carry on and make it sort of nice and easy to do mentally. So here, for example, we can just pretend it's 4 times 5, which is 20, plus the 2, so 22. 4 times 1 is 4, plus 2 is 6. So again, what we've now done is we've worked out 156 multiplied by 40. And again, you could check these separately, and that would be 6,240. We have to add these all together, so that's going to be 0. That's going to be, the line here, that's going to be 12. That's going to be 10, which means this answer is going to be 7,020. But remember, 7,020 is what we get from 45 times 156, but there was a remainder of 32 left over, so our actual number that got divided is going to be 7,020 plus 32, which is going to be 7,052. And of course, there's a really good way of checking this, which is if you were to do 7,052 divided by 45, your answer should be 156 remainder 32, which is probably not a bad thing just to do as a way of checking, and certainly if I was in an exam, that's the kind of thing I might do if I had a bit of extra time left over, and I'd sort of answered all the questions. I would then come back and check this way. I probably in the exam wouldn't immediately go and check this without finishing everything off. So that's what we'll do now. But anyone who wants a bonus point to get a bonus emerald, by all means do this in reverse as division and see if you get back to your answer. That's always a lovely way of checking. Number 4. The stronghold has some empty prison cells. Each cell can hold 8 prisoners. What's the minimum number of cells needed for 146 prisoners? Well, that's going to be 146. Divided by 8. 8 does not go into 1. 8 does go into 14 one time. The remainder is 6. I know that 8 8s are 64. I've happened to just learn that, so I could have listed the 8 times table, but I can just start off knowing 8 8s are 64, which means I know 8's going to go in 8 times remainder 2. Maybe I should write the 64 off out the way somewhere. I need somewhere to put this remainder 2, so I'm going to create a 0. I'm going to create a space myself so I now have somewhere to put the 2. I'm allowed to create the 0 because I'm not changing the number. Now I can do 8 into 20, but that goes in twice because I know at the start timetable it goes 8 and 16. So I can see here it goes in twice, remainder 4. I need somewhere to put that remainder 4, so again I can give myself a 0 and add in the 4. 8 into 40 goes 5 times, so my answer is that you would need 18.25 cells. That doesn't make sense though, so in real life, in real context, we can't have a quarter of a cell, so we are going to need 19 cells. And again, that's sort of showing an understanding of what remainders means, and it's from context. Sometimes you'll be rounding up, sometimes rounding down. In this case, if you have this many prisoners, you'll need an extra cell. There might be other questions where perhaps it asks, do you have enough? And if you only had 18.25 and you needed 19, well, you wouldn't have enough. It's those sort of questions where you've got to really understand the context of what's going on, just to make sure that you get the right thing, whether you're either rounding up or rounding down. So, last section. Really important thing just for us to note for this section is that we want to give our remainders as fractions. And this is the last method for dealing with these, and you would only normally do these if the question asks for them. And so I'm just going to do a quick example, a quick reminder of what remainder actually means. In fact, I'll use question A as the first one just to talk through, and in case you haven't seen this, we'll do A as an example, and then you can try the rest and come back and see the rest of me. So if I've got here 93 being divided by 6, I whiz through it like normal, so 6 absolutely does go into 9, it goes in 1 time, remainder 3, and then 6 does go into 33, and it's going to go in 5 times, and the remainder is going to be 3. Now there are two approaches. I could have just written remainder 3. That's sort of approach number 1 for dealing with it, and that's what we did at the very start. The new one that we've just seen is that we can, instead of writing the remainder here, we create a 0, and put the remainder 3 here, and that's going to be, by the way, that's going to be 5, so that's a decimal answer. The final method is kind of an amalgamation of the two, because it's sort of a bit more in terms of it gets us closer to understanding. It's just to realise that the word remainder is something remains to happen. It's like waiting to happen. So this remainder 3 is waiting to be divided. So if you think about what that means, is the 3 has not yet been divided by 6. Well, there's another way of writing divided by 6, and that is to say that the 6 is going to get divided, sorry, the 3 is going to get divided by 6, because it needs to happen. And we can write that using a fraction. And so the answer, as well as being 15 and 3 and 15.5, is also 15 and 3/6. And what's interesting about 3/6, I'm sure many of you have spotted this, is 3/6 is a fraction, and fractions can be simplified. And if you take the fraction 15 and 3/6, and you simplify it, let me just write that in a place where you guys can see. So you take 15 and 3/6. Let's move these all. Let's move these all out of the way so I've got a bit more room. You take 15 and 3/6 and you simplify it. The 3/6 is the same as 15 and 1/2. And that's just because, by the way, separate note, we can just do 3/6 is 1/2. And that's a simplification. If you've not done much fraction yet, don't worry, that's going to be part of the course. This is just sort of a final challenge, I suppose, at the end. But that does mean, look, 15.5 is the same as 15.5, which is probably something you already knew, and if not, certainly something you will know by the time we've gone over our fractions to decimals and decimals to fractions. So the approach, essentially, and it really is as simple as it's just to write the where you would have written R3, instead just take that 3 and write it over whatever number is here. So in this case, it's 3/6. Now, the final step would be to simplify. And I think it would be correct, actually, to write the final answer for this question as 15 and 1/2 rather than 15 and 3/6, because really, as a rule, we always simplify fractions, even if they don't ask us to. But all of these are equivalent, and so I think understanding all three of these is useful at different times. My favourite of all of them, and the one that I would want you to spend the most time focusing on, I think, is going to be this one, just because it's the most universal. Remainder 3 doesn't really mean anything, whereas a decimal, that's very crystal clear, but it's always a useful thing to be able to turn it into a fraction, because sometimes people are better with fractions, they're not used to the decimals as much, and so fractions are also a very useful thing to have in your arsenal. Okay, so that's sort of the two things, and by the way, of the former now, we're going to be doing all of these in this style, so I will just get rid of these ones up here. There's plenty of examples at the top one, but I'll just put this up here as a reminder, and now we have to just sort of crack on with this as we go through. So, 9 into 3, that goes 0 times. Let's shrink down this pen size. The remainder is 3. 9 into 32. Now that absolutely does go. 32 goes into 9 3 times, because it's obviously 9 times 27. Just quickly fix that. So 9 goes in 3 times, and the remainder is going to be 5. 9 goes into 54 6 times, because 9 times 6 is 54, so it's going to go in 6 times. Now the remainder between 54 and 57 is 3, so instead of writing R3 or the decimal, I'm then going to write that as 3/9. And 3/9 is a fraction I can simplify. That's going to end up being a third. So for clarity, I'm going to write my final answer down here at the bottom. So it's going to be 36 and 1/3 is my final answer. For C, we've got 12 does not go into 1, so the remainder 1. 12 does go into 19 one time, remainder 7. 12 into 75, well, 12 times 6 is 72, so it goes in 6 times. And the remainder is 3, so instead of writing 3, or R3, I'm going to do 3 over 12, because it's still to be divided by 12. And 16 and 3/12, that will simplify, so 3/12 will simplify down to a quarter. So the final answer is 16 and 1/4. But well done, guys. Even if you're getting to the 3/12 step or the 3/9 step and finishing there, that's still fantastic. I'll still even be inclined to actually give that a mark. That's doing really, really well. Right, 14 for this next one. So we've got 14 does not go into 5. Carry 5. If we were to do 14 times 4, that would get us to 56. I mean, it's going to go in 4 times. The remainder is going to be 2. 23 minus 14 is going to leave us with a remainder of 9. So I think it goes in 1 time, remainder 9. So instead of writing R9, I'm going to write 9 over 14. And I don't think that simplifies any further. 9/14. I think it's just the final answer, because in order to simplify, remember, you're looking for something you can divide them both by. And 14 doesn't go into 3, and 2 doesn't go into 9. So yeah, I think we're finished there. I'll just get rid of this one, or reposition the answer to this question just a bit higher, perhaps. Let's put that. Oops, moving around strangely. Let's separate that. Grab these. Just put the answer to that one off a bit, just so we've got a bit more room for this next E down here. Oh, in fact, what I can also do is I can also make that a little bit bigger. Just buy us some extra space. So 22 does not go into 1. It goes in 0 times. 22 does not go into 13 either. Still 0 times. So now we have to do 22 into 139. So for this one, I'm definitely going to need to write out my 22 times table. So that's 22, 44, 66, 88. This next bit's a little harder, because it goes across the barrier, so that's going to be 110. I was aiming for 139, so we might be able to fit one more in. So if we do 110 plus 22, we get 132. And I think that will go into 139. So 1, 2, 3, 4, 5, 6 times. And the remainder is the difference between 32 and 39. So that's 9 minus 2 is 7, so the remainder is 7 times. Now 22 into 75, well, I can see here that it's going to go in this many times, so it's 66. So the remainder between 75 and 66, I'll just do the subtraction, just make sure we don't get it wrong. So that becomes a 6, that becomes a 15. 15 takes 6 is 9. 6 takes 6 is 0. So yeah, the remainder is 9. I think, again, rather than writing R9, I'm going to write 9 over 22. And again, I also don't think that one simplifies. So my answer is 6 and 9 22s. In the same way here, just for clarity. I'm sorry, I should make that one look a bit clearer as well. Let's move these all down nicely. That's going to be 41 and 9/14. Right, last one is 25s. So does 25 go into 3? No, it does not. Remainder 3. 25 does go into 30. It goes in 1 time. Remainder 5. 25 does go into 55, because 2 25s is 50, so it goes in 2 times. Remainder 5. 25 does go into 55. We've just said that. That goes in 2 times. Remainder 5. But instead of writing R5, I'm going to write 5 over 25. But 5 25ths will simplify. So I think my final answer is going to be, so 5 25ths is going to become 1/5. So it's 122 and 1/5. And that is the answer, guys. So actually, in many ways, these can be almost as easy as just the R3 ones, as long as you remember what you're doing. Particularly, they're not quite as useful, perhaps, as the other ones where you end up having the decimals. So of all the question types you may want to do, I think decimals is the most the sort of highest priority when it comes to fractions. but it's really good to have all these skills because you never quite know what they're going to ask and in what format the answer will be most useful. Right, everyone, so I hope that was useful. I hope that made sense. If you've got any questions, of course, don't hesitate to bring them back to your tutors. That's always the best answer, is get the tutors to give you a helping hand. We're there to help for that exact reason. And any other questions as well, I believe there's also one more thing that you could do, which is on the portal, you can actually have a look at the other video that's up there, which lists out just some general hints and tips on division. So it's another lesson video where I just go through in a bit more detail sort of the instructions on how to do these types of division. So under the portal, underneath how to divide, you'll see there's another sort of dedicated video, and that may well be worth watching as well if you found any of these a bit challenging, if no other reason it offers you some additional practice questions. Right, everyone, thanks so much for your time. We'll see you again next week, and good luck. Bye bye for now.